It's Black Friday. Your e-commerce site just got hit with 1,000 orders in 10 minutes. Your server crashes. Orders are lost. Customers are angry. Revenue gone. Sound familiar? Here is the thing. This doesn't have to happen. What if you could handle that traffic spike without crashing, without losing a single order, and without your customers even knowing there was a spike? That's event-driven architecture. And in this 8-part series, we are building exactly that system. We will use Azure Functions, Service Bus, Next.js, and infrastructure as code. Let's dive in. Let me show you the difference. In a traditional synchronous approach, customer submits order. Then the system validates it, checks inventory, process payment, send emails, update analytics, and then responds. That's 8 seconds. Research shows a 1-second delay reduces conversions by 7%. At 8 seconds, you have lost 50% of customers. The worst thing is, if any step fails, the whole thing fails. Order might be lost. In an event-driven approach, customer submits and we immediately return order received. Everything else happens in the background. Response time, under 100 milliseconds. That's 80 times faster, with higher conversion and without losing any orders. It scales automatically and we handles any spike. Here is the key insight. We separate accepting order from processing it. First, we accept the order, store it in a guaranteed delivery queue, and return instantly. Second, our background processor picks it up, handles all the work, and retries if anything fails. This makes our system resilient. We also have independence because components don't block each other. Let me show you how we build this. Let's break down the architecture. I'll explain it in 2 passes. First the big picture, then the details. User submits the order, then the HTTP function receives it, publishes to Service Bus queue, the queue function processes it, and application insights monitors everything. That's it. 5 components, simple and production ready. Now let's dive into each. The first component is our front end. This is where users submit orders. It's built with Next.js, TypeScript, and Tailwind CSS. Hosted on Azure Static Web Apps, which means it's globally distributed. Think of it as your storefront. The second component is our HTTP function. This is like a receptionist at a busy restaurant. They take your order, write it down, hand it to the kitchen, and give you a receipt. Fast. Here, our Azure function validates the order, generates an ID, publishes to the queue, and return 201 created. Done in 50 to 80 milliseconds. The third component is our Service Bus queue. This is critical, so let me repeat. Service Bus is like a guaranteed delivery service for data. It never loses messages. Features include message persists until processed, even if everything crashes. Built-in retry logic with up to 10 attempts. Dead letter queue where failed messages go for investigation. And first in first out ordering, so we process orders in sequence. This is why we can promise customers your order will be processed. The fourth component is our queue processor. This is the back office doing the actual work. It automatically triggers when messages arrive. It handles inventory checks, payment processing, confirmations, and status updates. If it fails, message goes back to the queue automatically. After 10 failures, it goes to the dead letter queue for investigation. The fifth component is our application insights. Every operation is tracked. Orders per second, processing times, error rates, queue depths. We can also trace a single order through the entire system. We will cover this in detail in part 5. Now let's look at the complete flow. User clicks submit orders at 0 milliseconds. HTTP function validates and publishes at 50 milliseconds. Returns success to the user at 80 milliseconds. User is happy. Message sits safely in queue, waiting. Processor picks it up and processes in 2 to 5 seconds, all logged to application insights. User waits 80 milliseconds. Processing happens in the background. That's the magic. You might be wondering, Azure has event grid too. Why Service Bus? Great question. Here is how I decide, and you can use this framework too. Ask yourself, can I afford to lose this message? If the answer is yes, missing a few is okay, use event grid. If the answer is no, cannot lose this, use Service Bus. The event grid pattern is fire and forget. Use it for button clicks and user analytics where missing a few is no big deal. File uploaded notifications where you can retry if needed. IoT sensor readings running at 1000 per second where some losses is acceptable. Or application telemetry. Think like this. Hey, something happened. Anyone interested? That's event grid. Service Bus, on the other hand, guarantees delivery. Use it for orders. You cannot lose a $10,000 order. For payments, where every transaction must complete, for financial transaction, where compliance is required, for inventory updates that must be accurate. Think like this. This must be processed, no exceptions. For our order system, we need guaranteed delivery, retry logic, dead letter queues, and first in first out ordering. That's Service Bus. Event grid is amazing, just not for critical transaction. Use the right tool for the job. A quick tech stack rundown. We are using Azure Function, TypeScript, Next.js, and Bicep for infrastructure as code. The pattern you are learning here works everywhere. Payment processing, email campaigns, data pipelines, inventory updates, notifications, reports generation. It's always the same. Accept fast, queue reliably, process asynchronously, monitor everything. Once you understand this, you can build production systems in hours instead of weeks. We are building this over 8 parts. Today was architecture. Next up, deploying infrastructure with Bicep, building the functions, adding monitoring, creating the front end, and finally, CI/CD automation. Each video builds on the last. By part 8, you'll have a production-ready system. For the next parts, you will need a free Azure account, Node.js, Azure CLI, and Azure Function core tools. Total setup time is 50 minutes. Everything is free tier during development. Part 2 drops soon, where we will deploy the entire infrastructure with one command. Subscribe to get notified when it's live. See you there. Happy building.